Professor Deb here. Welcome to Technical Mathematics. In this video lecture, we're going to be taking a look at the properties of logarithms. There were previous videos done on explaining the exponential functions and the logarithmic functions and changing between exponential to logarithmic and then back from logarithmic to exponential. Now in this case, we want to try and start to look at properties. Now what are properties? Sounds like a long word, but what it means is properties are what we do in everyday mathematics. Adding, subtracting, multiplying, dividing, and raising to a power. And that's just what we're going to do in this video, only with logarithms. At any time, pause or stop the video to examine the material more in depth. Let's get started. All right, here's our properties, nicely written out for us. Now, we're usually used to this written as log to the base b of x times y. And we know that we can have various bases, but we know that the common base we usually work in is 10. That's the common log base. So we're going to pretty much ignore this base and just work with 10 right now in order to get the idea of what we do with the properties down. All right, so we'll be dropping that out of the picture. All right, log of x times y is equal to the log of x plus the log of y. So when we multiply variables of a log, we can add each one of the logs. All right, let's put some numbers with it. That always helps. So we'll take the log of 35. Now, 35 is what two numbers multiply together. We would say 5 times 7, right? 5 times 7 equals 35, yep. All right, let's split that apart then. The log of 5 plus the log of 7. So the log of 35 will equal the log of 5 plus the log of 7. Now I know what you're thinking. Why do we just spread this out and make this a longer problem? Well, we did that because many machines in industry and many programs in a lot of industrial functions work with these base logs. I shouldn't call them base logs, but numerical values of logs, log of 2, log of 3, log of 5, and log of 7, basic numbers. And they use these readily to work different functions. So that's why we are now going to take all these complicated logs, like 35, and we're going to break them down into logs of basic numbers. Eventually we're going to be able to cancel some of these logs out to make it simplified and so forth. That's all in our future, and I know you're looking forward to it. Okay, let's go on to property 2 before you get too excited on me. This is a log of a division problem, x divided by y. Now how does that break down? Log of x minus log of y. So when we're dividing, we subtract the numbers. Again, when we're multiplying, we add the numbers. Dividing, we subtract the numbers. All right, I know you want an example. How about the log of 3/5? Well, that's not too complicated, you're going to say to me. That's the log of 3 minus the log of 5. Right? Again, division, we're using subtraction. All right, let's go to our third property, I'm sorry. The log of a variable raised to an exponent. Okay, now this didn't quite look right, but what we did was we took that exponent and we put it in front of the log. So now we have an exponent that becomes a multiplier, and we remain with the log of the variable. All right, let's get the numbers. Let's get those down. Log of 5 to the third. That is the same thing as saying 3 times the log of 5. Right? 3 times the log of 5. So again, I'm looking for those base numbers. Here they are. 5 and 7. And I'm always doing something with those base numbers. I'm either adding them, I'm subtracting them, or I'm multiplying something by them. And then property 4, 5, and 6, I didn't give us a lot of room here, but they're just the base logs. Let me write them down for you. Log to the base b of 1 equals 0. It always equals 0. No matter what base, it always equals 0. And log to the base b of b equals 1. So if we have log to the base 10 that we're used to of 10, it equals 1. Log to the base 8 of 8 equals 1. That'll come into play. And one more. Log to the base b of b raised to the n is equal to that exponent n. We'll see how that comes into play. These are the ones that we're going to concentrate on. Ready? Here we go. Log of 5/4. Remember that property that we worked with? When we had to divide it, what did we do with divided? What did we do when we were dividing? Subtracting. Let's go back. Better not do that. I have to pick up the pen each time. Okay. Log to 5/4. We can break that up into the log of 5. Remember, when I'm dividing, I subtract. I subtract the log of the denominator. Okay. The log of 28. Now, remember, we want to work with 2s, 3s, 5s, and 7. So let's break this down. We've got 2 times 14 and 2 times 7. So we want to rewrite this as the log of 2 times 2 times 7. All right? So then we got the log of 2. Now we're multiplying. What did we do when we multiplied? We added. Exactly. So we've got log of 2 plus the log of 2 plus the log of 7. Okay, there's the multiplication. All right, now we've got the log of 1 over 5x. All right, let's rewrite it a little bit easier first. Log of 1 minus the log, but remember, here's our minus for the division. That's the log of 5x. All right, now, what did we say? Those properties I said not to pay attention too much. Log of 1. What was log of 1 equal to? It was equal to 0. All right, so we don't have to contend with that part. But this part we do. What we have here is the log. Now we're multiplying. The log of 5 plus the log of x. Now notice I've put them in parentheses because what you've got to remember is you're dividing the entire 5x. So you've got to subtract the entire log of 5x. So what that then equals is negative log of 5 minus log of x. You see how that changes that just a little bit? All right. How about you try one? Think you're ready? Write this as a sum or difference of equations. You're going to break that 5 into 2, 3, 5, 7, or 11. That makes it a little easier with that hint, doesn't it? So stop the video and try that one. And look for the guided solutions. Okay, hopefully you didn't have too much trouble with that. We want to go the reverse direction. Here we want to write them as a single logarithm. So we've got log of 3. Let me pick up my pen again. Okay. So we've got log of 3 plus the log of 13. So what does that equal? The log of 3 times 13. Remember, when we multiply the variables next to the log, we added them. So that becomes the log of 39. All right. I think going this way actually is a little easier, but maybe you don't think so. Just wait. We'll get a little bit more difficult. All right, before you answer that question. Here is our another one. Let's see what we've got going here. We've got a plus and a plus. So that shouldn't be too bad. Same thing. Log of 3 times 3 times 5. As long as I can do that multiplication, I end up with the log. 3 times 3 is 9, times 5 is 45. Log of 45. All right, here's another one. Here we have log of 5. We're adding log of 7, and we're subtracting log of 11. That looks like a equal sign, so let's make sure we'll circle them. That clarifies it a little better. So what do we have? The log of 5 times 7, put that in parentheses so it's a little clearer to look at, over log of 11. So we can rewrite that as the log of 35 over 11. All right, had to throw this in there, didn't I? Just when you were getting the hang of it and saying, this isn't too bad. Now I throw this one in here. Just got to give you a little bit of a challenge. Okay, first let's rewrite it. We've got a plus and a minus. That much we pretty much know what to do with. It's these fractions that's just going to kill us again, right? I love fractions. Okay, so let's rewrite it. we've got log of 3/24 times 4/7 divided by the log of 1/3. All right, now we're going to rewrite that into one logarithm. So how do we do that? The log of 3/24 times 4/7. And how do we get rid of a fraction in a denominator? Do you remember those fractions? We invert it and put it in the numerator, right? We invert it, right. So we'll put 3 and 1 up here. Hopefully you remember your properties of cross simplification. We can take this 3 out of here and take 3 out of here, and we should get 8, right? Can we simplify? Yes, we can make this a 2 and this a 1. So what do we end up with? The log equals the log, what do we have left up top here? 3. And what do we have on bottom here? 2 times 7, which would be 14. So the log of 3/14 is what all of that is equal to. You didn't think it was going to be that simple, did you? All right. Here's another one. What we need to do is look at this one is because we need to recognize the exponent property. Remember when we put something in front of the log that became an exponent. So what we have here is the log of 3⁷ minus the log of 8⁵. All right, now we have to deal with our minus here. So we'll say that is the log of 3⁷ over 8⁵. And if you do that multiplication out, you probably need a calculator on this one. 3⁷ is somewhere around 2,187, I think. And 8² is 64. So there we go. That's your answer for that problem. So remember that those numbers in front come up to be exponents. And at the same time, we add a negative sign so that we brought it down in the numerator. Try one yourself. I kept the fractions out of it for you, but you're still going to have to change the 17 and the 23 into logs of 2, 3, 5, 7, and 11. Oh boy, you better go more than that with prime numbers. Aren't 17 and 23 prime numbers? Yeah, so I think you're going to have to rewrite that as prime numbers. Let me just, I don't like the way this came out for you, because we've been working all along with 2, 3, 5, and 7, and 11, and all of a sudden I end up with prime numbers up here. So let me just go ahead and do this one for you. What we have is log of 17 over 23. We can't break these down because they're prime numbers. Sorry about that. Bad example, but I'll give you another one to make up for it. All right, now what we're doing here is, if you put in your calculator, log of, to the base 10, log of 2, you'll end up with the number 0.3010, and so forth. So now, what a computer program is going to do is take the log of 36 and break it into 2s, 3s, and 5s and automatically give it this answer. So we're just going to emulate what the computer's doing so that you understand what's happening in there. So here we have log to the 36. And again, we've got to rewrite that. Should be pretty good at that now. Let's see, what do we want to say? 4 times 9? 4 times 9. Okay, so what is 4? That's really 2 squared, isn't it? If we break it down into prime numbers of 2, 4 is not a prime number. 2 is the prime number. And again, 9, see, we want plus. So we'll go with log of 3 squared. That gives us log of 36. Now let's rewrite this again. We know to bring those exponents down in front. So we've got 2 times the log of 2 plus 2 times the log of 3. And now here we've got a value for log of 2 and a value for log of 3. So we've got 2 times 0.301 plus 2 times 0.4771. And that's a lot easier to break down. That actually is what your computer program is doing, is once you've got it broken down and you put it in there, it's going to put these values in there and come up with a final number, which is what we're trying to do in this part of the video. 1.5562 should be your value. Let's try it again. Here's 45 over 8. All right. First of all, what do we have to do with 45 over 8? Division becomes a subtraction, doesn't it? You want to rewrite that first? Okay, so we've got log over 45 minus the log over 8. All right. What prime numbers does 45 break down to? Let's see, we'll put this little inverted thing here. We've got 5 times 9, if I remember right. And that 9 will break down into 3 and 3. And what about our 8 here? Doesn't that break down into 2 times 4, which breaks down into 2 times 2? It's going to take a while for us to write this out, isn't it? Okay, let's get started. We've got the log of 5, and we add the log of 3 squared, and we're subtracting the log of 2 to the third. These are basic algebra skills. Go back to a previous video to review this if you need to. I'm kind of skipping through it, hoping that you already have this understood. Okay, log of 5 plus log of 3 squared. We're not done yet, are we? We can break this down a little bit further. Log of 5 plus 2 times the log of 3 minus 3 times the log of 2. All right, now we've got it all broken down. And again, those same numbers we're going to put in for log of 2 way over here. I should have started the other way. Log of 3, I'm going to sneak through and put it here. And log of 5 Should have started with it first. Oh, have we got a crazy map? Let's try and rewrite this. Log of 5 was 0.699 plus 2 times the log of 3, which was that 0.4771. Okay, minus 3 times the log of 2, which was the 0.301. And you put that all in your calculator. I'm not going to try and do it by hand. And you should get a final value of 0.7502. That's a 0. 02. That is your answer. All right, not so easy this time. Log of 30. Break it into prime numbers. 2s, 3s, and 5s, and this time I didn't give you a ringer. You should be able to break those down. Stop the video, try this on your own, and then look for the guided solutions. Okay, I think this is the one I'm going to leave you with. It looks awful, doesn't it? Log of 4,500. Not as bad as it looks. Let's get through it and call it a day. What we could break this down into. This is 100, right? So that's 45. So isn't that 10 times 10, or 10 squared? And what did we say 45 broke down to? 5 times 9, right? And the 9 broke down to 3 times 3. All right, all we have to do is rewrite it. Let's start with this part. This looks interesting, doesn't it? So we've got the log of 10 squared plus the log of 5 plus the log of 3 squared. Now you're probably wondering why I'm so interested in this log of 10 squared. What is log to the base 10 of 10? Do you remember? Log to the base 10 of 10 is 1. So we've got 2 times 1. That's why I was so anxious to get to it. Log to the base 10 of 10 is 1. Oh, that makes that so much simpler than 4,500, doesn't it? Okay, so log to the base 5. What did we say 5 was? 0.6990. And this breaks down to 2. Remember, we bring that 2 into a multiplier. And 3 was 0.4771. So log of 4,500 breaks down to an equivalent value of 3.6532. Isn't that interesting?